This is actually from yesterday. You should have had this yesterday. So if you weren't in class, here's the video for it. I'm going to talk similarity. Okay, two figures are similar if they're the same shape, but not necessarily the same size. Right? So as you can see, these two figures are the same shape, but they're not the same size. You probably don't have the word bank on your paper there, but that's okay. We can still utilize it. Similar figures always have corresponding angles that are congruent and corresponding sides that are proportional. Now, what is a proportion? What is proportional? Somebody stated the other, proportional is part of. No. Proportional. How do we create a proportion? I'm going to compare sides and try and follow this. I'm going to compare left to left. The smaller image is my pre-image as we read left to right. The larger is my image. So I always want to do image over pre-image, and that gives me the proper scale factor. So QT divided by a D, that is a ratio. I'm comparing left side to left side. The other ratio I'm going to prepare is either the top to the top, right to right, or bottom to bottom. It doesn't really matter. So we'll go TS to DC. And I did a couple other ones in class, but this is a proportion. Okay? Proportion. Two ratios set equal to each other is a proportion. This is going to be the easier way for us to help us find sides, really. These two figures are similar. It tells me if we go back and look. So I don't have to decide if they are. It tells me they are similar. We would have the pre-image and the image, all right? And since they're similar, corresponding angles are equal. The measure of E is 135, so the measure of W has to be 135. F is 90, so X has to be 90. Pause and go ahead and fill in the rest of those. I'm not going to do all that for you. Write a ratio for each pair of corresponding side lengths as a fraction, and then simplify. Here's what they want for this. So they want us to write a ratio comparing corresponding sides. So I'm going to compare the top to the top. So WX over EF. That is what they want. Now we can do it numerically. So we compared it with using our letters. Now we're going to compare it numerically. 18 over 6. What is 18 over 6 reduced to? That reduces to 3. Guess what my scale factor is? My scale factor is 3. We'll do one of the other 4. You will do 2 of the 4 by yourself. So let's just compare again. Let's go left side to left side. WZ to EH. And you should be following along with this. Now I can do it numerically. 15 over 5, excuse me, which is 3. Makes sense. My scale factor is 3. They should all have the same ratio. You have 2 other ones to do. Pause and do the other 2. I'm going to be looking for all 4. Right? So the ratios of the pair of corresponding sides is equal. The ratio is called the scale factor. We see that come up again. So the scale factor for this example is 3. So that means that the side lengths of, how are we going to say this? I can start with any letter I want. I can start with X, but let's start with W. W, X, Y, Z. Notice I started W, X, Y, went to Z. So if I state the other one, I got to do the same with its letters. Are 3 times the side lengths of E, F, G, H. And we say that those are similar. Notice the symbol here, the squiggly. Squiggly is read as similar to, so we can write it. EFGH is similar to WXYZ, right? Now it doesn't matter whether we do pre-image or image there, apparently. It's just stating one figure is similar to the other. So find the missing side lengths of the similar figures. These two figures are similar. So how are we going to find their side lengths? First of all, we have to determine the scale factor. So how do we determine the scale factor? I pick 2 sides that I know the values of. I know the hypotenuse and I know the hypotenuse. Well, first, second. So pre and image. Figure get bigger, figure get smaller. Figure is getting smaller, so my scale factor should be a number between 0 and 1. So find the scale factor by writing the side lengths as a ratio or a fraction. Remember, it's image over pre-image. So 26 over 39. Does it reduce? Does 26 over 39 reduce? And yes, it should reduce to 2/3. So my scale factor being 2/3, the side lengths of JKL are 2/3 times the side lengths of, we said JKL, we must say CED, so CDE, not CED, CDE, erasers don't write, Mr. Wilson, CDE, all right? And it says now write and solve a proportion to find x. So I'm going to use this scale factor, all right? I'm going to compare corresponding signs. Let's go ahead and find x first. So x corresponds with 10, but remember, pre-image, image. How am I going to do this? I'm going to use my scale factor, which is 2/3, because that is one ratio that I can use. I compared image over pre-image, right? So image, pre-image, image, pre-image. I have to set this other ratio up the same way. So what's the side in my image and pre-image that I want to find? 10 and x. That's what I'm going to compare. 10 over x. Notice image, pre-image, image, pre-image. We always set up the ratio that way. So now I'm going to scroll down a little bit and solve. How do I solve proportions? Right here. You cross multiply. Now watch what happens when I cross multiply. 2 times x is 2x. That's equal to 3 times 10. And I didn't multiply those two. Why did I not multiply those two? Well, let's assume I did, and I got 2x equals 30. What do I have to do here? Yes, I have to divide by 2, right? So x is equal to. Well, I'm going to divide by 2 over here as well, but unlike over here, I don't have to divide 2 into 30. I'm going to see if 2 will go into 10 or 2 will go into 3. 2 goes into 10 5 times, and 5 times 3 is 15. Well, I know half of 30 is 15, so this way was a little bit shorter of a shortcut for me. Now it wants me to find y. Next, write and solve a proportion to find y. I'm going to use the same scale factor. 2/3 is going to be equal to, remember, I went small to large. So I'm going to do the same thing over here, comparing my y value. Small to large. Small to large. Corresponding sides. So y over 36 is my next ratio. Y over 36. I cross multiply, because that's how I solve proportions. 2y is equal to 36 times 3. I'm not going to multiply 36 times 3 because that's going to be a big number, but I am going to divide by 2. 2 will go into 36 how many times? How many times will 2 go into 36? What's half of 36? Suddenly Mr. Wilson is drawing a blank right now. Okay? He's having a Wednesday. A Monday on a Wednesday. Okay? Oh, and no wonder he's having a Monday on a Wednesday. Because what did he do? 3y. This should be 3y. So he's got to go back and erase. Helpful if you show your work, right? You do your work in your head, you wouldn't have seen that mistake. You'd have been frustrated. So 3y equals 36 times 2. And I divide by 3. I knew that was wrong because in my notes it didn't seem right. Done this 2 other times before. How many times will 3 go into 36? 12 times. 12 times 2 is 24. And is 24 a reasonable value for y? Better be less than 36. And that is true. And now we pop over and we look at are figures similar? State if the polygons are similar. Polygons are similar in 1 of 2 ways. 1, if the angles are all equal. And 2, if I have the same ratio for all sides. Okay, so does it meet the criteria? So I'm looking at this and angles. Well, remember the arrows indicate parallel. So if the arrows indicate parallel, that means that these two, top and bottom, are parallel, and here's my transversal. How do I classify these two angles? And I'll just go ahead and write in angle 2 right there. 70 and angle 2 are called same side interior angles, and same side interior angles are supplementary, which means they add up to 180 degrees. And you thought, why do I need to worry about knowing these angle measures again? Here's a perfect example. In a parallelogram, same side interior. So 70 plus what is 180 degrees? 70 plus what equals 180? Well, x is equal to 110. So this angle measure right in here is 110. If that's 110, this is 110, this has to be 70. So I'm pretty sure that all these angles inside both of these figures are going to be the same. Now the only thing I have to do is I have to look at and I have to say, hey, wait a second, do all of these sides have the same ratio? 35 over 42. So that's the top over the top, 35 over 42. Or probably 42 over 35, but either way we make this ratio, it should be consistent. 35 over 42, 35 over 30. Are these ratios the same? These ratios are not equal, so the figures are not similar. And then we move on to the next one. Gee, look at it, and you better write down some evidence. I'm not going to for time's sake because I'm running out of time here. Top to top, 48 over 40. Left to left, 48 over 40. Right to right, 48 over 40. Bottom to bottom, 48 over 40. All the same ratio. Do you think all the angles are going to be the same? Yes, similar. Make sure you write some evidence down for these. Ask questions too, not that hard.